Hello YouTube! Welcome to part 2 of the CNC build. Last time we made a functional plotter. Today I'll go over the steps taken to convert it to a better packaged and more refined laser cutter and engraver. For the project I purchased a 1 watt 405 nanometer blue laser from Banggood. This was literally the cheapest 1 watt laser I could find, about half the price of any other. Along with the aluminum mount for a few extra dollars, it seemed great. But you get what you pay for. In this case, the detail is in the small print, where it mentions that it's a replacement model for a very specific machine, and if not used in that machine, that the power will be, quote, less than 1000 milliwatt. Make sure you do not mind, unquote. This is no understatement, and it took some doing to get around. The laser module has a built-in driver of some sort, and with some experimentation I noticed that you get full power when it first powers up, but then it quickly drops to a fraction of that. That low power level is too low to be useful. However, if we pulse it on and off, we can use it. So here's the circuit I came up with to do that. A basic 555 timer circuit generates about a 10 Hz square wave. I used a single transistor as a switch. The Arduino signal connects to the base and enables or disables the pulsing signal. The lasers run through an NPN bipolar power transistor, also being used as a switch. A MOSFET might have been better, but I didn't have one handy. So, when the Arduino sends the activate signal, the pulses pass to the power transistor, which pulses the laser on and off. This seems to be working quite well, though it does leave dotted lines if you move too fast. To get this off my bench, it'll need its own power supply. I found this nifty T4012-5 supply that can plug into the wall and gives 2 amps on both 12 volts and 5 volts, preventing me from needing an additional step-down converter for the 5 volt parts. To power the laser, the specs listed as needing exactly 5 volts and up to 1 amp. However, as little as 4.9 volts, it barely lights up. With some experimentation, I found that I actually get best results at about 7.4 volts, so I need an additional regulator to reduce my 12 volt line down to 7.4, and preferably to limit it at 1 amp. This D-Rock regulator does both very well, and it came with a nice case and display. To control the AC current, I added a nice machine switch with a box rated for much more than this machine will ever draw, and then used an old PC power cord. These lasers are no joke. Proper eye protection is absolutely necessary. I have these glasses to protect myself when working with it, but it quickly became obvious that some solutions needed to protect the kids or anyone else that may walk into the room while it's operating. One option would be to fully encase it, but it's nice to see what's happening while it runs. I found this laser shielding acrylic from JTech. With some drilling, cutting, and gluing, I made an enclosure that mounts to the laser. My apologies, I filmed the build for this encasement to make a separate video, but my laptop crashed and I lost all of that footage, so I can only show you the end product. Here it is, and it works. The push buttons I use for end stops work most of the time. They take more pressure than is desired, so the tension is not as consistent as I want. I ordered some better ones. Now that they came in, I replaced the push buttons with lever-style switches, which is what almost everybody uses, and for good reason. They work much better. Start with these if you can. While working with this, I've decided that I'd like some extra buttons to perform tasks without having the PC connected. I decided to add 3 buttons to the chassis. I ordered a bunch of these large beveled panel mount buttons, and they should work great. To mount the buttons, I used a small 70 by 45 millimeter project box. I drill 3 1/2 inch holes in it and then paint it black. The buttons mount to the top of the box, and the bottom can be mounted to the frame. To make these buttons and the laser work, we need a few code modifications. First, we comment out the servo library and parameter. Then we define the pins for the laser, pin 11, and for the new buttons, A0, A1, and A2. In the setup function, we initialize the buttons and end stops as inputs, and then set the laser pin as an output and make sure it's off. Now we make a new function to check the button state and act on it. First, we read the state of each button and save it to a local variable. Then, with a series of if checks, we act on any button that is pressed. For button 1, if pressed, we want it to move the tray forward so we can load paper onto it. So, we turn the laser off just to be safe, set the speed to max, and then move the tray to 175 on the X-plane, which is nearly the max, and 120 on the Y, which will place the carriage in the center, using the line function. Button 2 will home the carriage and tray at 0, 0. This is easy. We just turn off the laser and then call the setup controller function. And finally, for setting the laser focus. We want it out in the center so it's easy to get to. So we move the tray and carriage to 90 on X and 120 on Y with the line function. and then turn on the laser so we can adjust it. This monitor buttons function is then added to the loop. And finally, I made a few changes to the setup controller function to convert it from analog read to digital read on the end stops. Here are the new buttons in action. As I mentioned last time, the machine's a bit slow. This is max speed. So I'll speed it up here, about 5 times speed. One component that was added a bit late, and you should work it into the design from the start, is a fan. Not for heat, for smoke. It may seem obvious now, but I was having strange issues with inconsistent lines. Even on a straight line, it would burn more in some places and less in others. I could see it getting brighter and dimmer when it cut. I thought it was some issue with my power. That was until I noticed that it cut less when it appeared brighter. The smoke scatters the light, and that weakens the cut. Adding a fan to blow the smoke away helps with this a lot. Using the same 1/4-inch MDF as I used for the table, I cut a back and top plate. This is painted black and then is connected to the frame with bolts and brackets that I cut from aluminum sheet. Unfortunately, I lost this footage also, but you should be able to get an idea from the finished product. This provides a nice wooden deck to mount all of the electronics on. Like all of my other projects, I like to have everything pluggable. The idea of having to unsolder wires to replace a switch or motor or whatever is just not appealing to me. Solder them if you like, but either way, we still need to connect it all. I use strip board for my main distribution point. The 5-volt ground and 12-volt power comes in here, and then I used keyed Molex connectors to route all of the signal lines and power lines from all the other components. Then 2 rows of female pin headers are added to mount the Nano, along with a few resistors and LED indicators for end stops. And finally, I add a voltage display for the 5-volt line, because I have it, and I like blinky things and displays. And, as much as I hate to admit it, this is held in place with hot glue. The power switch, power supply, buck converter, stepper drivers, laser control board, main distribution board, and function button box are all mounted to the top plate. A few twist ties and a zip tie here and there to tidy the wires, and we're ready to go. As you can see, lots of blinky lights. Alright, so let's print something. I made a drawing of my logo in Inkscape and exported it as Gcode the same way I demonstrated last time. This first pass is detailed, so I have the machine set to move pretty fast so that it only engraves rather than cut. Still, this is sped up. The actual run took 35 minutes. The second pass is the cutout box, and yes, this would be way quicker to do with scissors, but that wouldn't make for a very good demo. For more complicated cuts, it makes more sense to use the laser. I reduced the speed quite a bit to make sure it cut well. This actually took 20 minutes. It sped up quite a bit here. There we go, all done. Alright guys, please post any suggestions or questions in the comments. Click like if you like this, and subscribe to see more. And until next time, thanks for watching.